Thank you and welcome. Good afternoon, everybody, to this afternoon's session from Race for 2030, the race to net zero business. It's great to have you here and we're looking forward to presenting some really exciting work that we have done here at Race for 2030 and also hearing from you today. I would just like to encourage you today, before we get started, to place your questions in the chat for the meantime, but also recognize that we're going to have an opportunity for an open discussion and a breakout session as well at the end after we've heard from our presenters as well. So we'll have a chance to work face to face, but from now it'd be fantastic if you could put your questions into the chat. So before we get started, I would like to acknowledge the Gadigal people and the Wangal people of the Eora Nation as the traditional custodians of the country where I do most of my work here in the inner west of Sydney, and I recognise their continuing connection to the land and waters of this place. I acknowledge that they have never ceded sovereignty. I pay my respects to their elders past and present and extend to that respect to all First Nations people who are here present today. So today, the topic is the race to net zero business. We heard from this yesterday in our first sessions hosted by A2EP. I guess the difference here today is that we are speaking from Race for 2030 Cooperative Research Centre, where we are focusing on the race, I guess, for net zero in the context of what has not been done yet, the context of research, as opposed to, as Jared has mentioned earlier, the here and now. So really the rationale for this is because while a big audacious goal is useful for galvanizing action, a clear pathway to achieving this goal of net zero is even more important. And we're finding that while an increasing number of businesses are committing to net zero, there is still space to learn what that means and also to pave a path to get there. Really what we want to see is how we can viably achieve it and what is required to ensure that these claims of net zero can be verified. So we're looking forward to hearing from some excellent speakers today on this topic, who I think will be starting to delve into the issues that we are exploring at Race for 2030 under our strategic challenge of net zero for business. Just as an introduction to Race for 2030 and the Race for Business program. Oh, thank you. That's fantastic. So what I just said there is up on the screen. My name is Danny Alexander. I'm the program leader for Race for Business, and the Race for Business program is all about energy productivity for business, which is why we're here in collaboration with the Australian Alliance for Energy Productivity today. This is really the summary of our strategic challenge for the race to net zero for businesses in Race for 2030. And this is really broken down into 5 different elements, really helping businesses better understand and communicate the net zero challenge, helping businesses strategize their net zero response, and looking at scope 1, 2, and 3 emissions. And what I mean by that is helping businesses develop pathways to reduce their direct emissions or scope 1 emissions by particularly decarbonising hard to abate processes. Secondly, we're looking at scope 2 emissions by helping businesses develop pathways to shift to 100% renewables. And thirdly, we're also very interested in value chains, both upstream and downstream, and we're keen to help businesses to develop pathways to support those decarbonised value chains. So I think on the next slide, fantastic, thank you. We have a lineup of excellent speakers from some of our race partners. We'll first hear from David Roche, who is a research principal at the Institute for Sustainable Futures at UTS, who is leading the Green Wave project under Race for 2030. We'll then hear from Andrew Weller, who is the Business Development Manager at Glaciem Cooling Technologies, who is leading a fast track project under Race for 2030 on innovative thermal energy storage. We'll then hear from Steve Hoy from Enosi, who has a a really interesting concept around true zero and what that means, and how UNOSI is working on energy traceability to make true zero a reality. And finally, we'll hear from my colleague Dorota Bakal from Race for 2030, who is our in-house capacity builder, and she'll talk a bit more about net zero for your business. So without further ado, I'd love to hand over to David Roche, who should be online to tell us about the Green Wave.
Great, thanks, Danny. Yes, I'm going to be talking about the Green Wave project, which, as Danny mentioned, is a project under Race for 2030. It is led by University of Technology Sydney and involves Curtin and Monash universities. And we also have a number of industry partners, including New South Wales Department of Planning, Industry and Environment, supporting it. Next slide, please. So the project objective is we set out to identify how net zero strategies can more deeply engage community and business partnerships to deliver greater trust, legitimacy and social value. So let me try and unpack a bit of what that means. Next slide, please. The project is based on a few key ideas. The first is the idea of universities as anchor institutions. So the idea that universities are essentially special places. They involve the core business of teaching and research, but they're also major institutions with a particular location. They're often major employers for the area in which they operate. They have close links to the local community. They have major links to things like procurement. And this is also linked to the idea of community wealth building. So can we invest locally to drive local economic recovery? Next slide, please. A second idea is the idea of universities as living laboratories. So universities are ideal places to bring together the research and education, that's the core business of a university, and to look at things like campus operations in partnership with local communities and the local precinct, and to deliver on the United Nations Sustainable Development Goals to address climate challenges. And so we'll talk about that a little bit later. Next slide, please. And a third idea is about investing for impact. So this is a kind of standard net zero pathway. Forgive the axes being reversed, because I think we want to be moving from the bottom quadrant towards the top quadrant, towards a better world. And so a standard emissions pathway sees a kind of business as usual trajectory where things are kind of, moving along or perhaps even getting a bit worse. And we want to implement a whole lot of emissions reductions to get us on a pathway towards net zero. But doing that on its own is not going to get us there by 2050. So then we implement things like offsets, and that gives us this net zero pathway where we get to net zero emissions sometime between now and 2050. Next slide, please. But what we're trying to look at is how do we invest for greater impacts, particularly with the university. You could ask questions such as, should a university, for example, be investing in offsets when a university's core business is churning out graduates and doing lots of really interesting research? Could we perhaps use that money and spend it and invest it more wisely to create greater impacts? And one of the key questions that we've been trying to address and grapple with, and which we have struggled to get an answer to, is how do we actually account for that? Is there a way that we can incentivize these kind of grander impact pathways? Next slide, please. So just to give you an example of a climate impact lab. So this is based on this idea of using a university as a living laboratory. So we've used this to address some of the key challenges. For example, we're applying this model to social housing in the local community and looking at how we can decarbonise the local community housing. We're located close to Glebe, where there's a lot of social housing. There's also some owner-occupied housing, and how can we link up those two groups of people within that suburb, and how can we invest in that community to decarbonise? So we're trying to establish a climate impact lab that will address some of these deep specific climate challenges, and we're harnessing the expertise from across the university. It involves both research and education, and involves links with the community, industry, local partners for things like delivery. And we're applying a collaborative, very transdisciplinary style of thinking to solve these challenges. And then once we can develop solutions, we're trying to test, accelerate, and scale them. Next slide, please. And finally, just another example of the sort of things we're looking at as part of the UTS net zero strategy that we're developing through the project. is this idea of having an integrated approach to addressing scope 2 emissions, i.e. your electricity emissions. Involves direct power purchasing agreements. So we're using the university as an anchor to fund building of new renewable energy assets through direct power purchasing agreements. And also at the same time setting high standards for those PPAs. We're looking at things like better building management. How can we manage demand to not only reduce running costs, but support 100% renewables, the sort of true zero idea that I think Steve is going to talk about later, including a battery, but perhaps oversizing that so that we can then offer a retail offering to some of our local community, particularly things like staff and students, taking some of that excess capacity and offering through a special tariff 100% renewables to, as I said, to staff and students, to have greater impact beyond just what we would achieve if we were to invest solely in the operations of the university, and then pilot this strategy beginning with a single building. And I think that's my last slide. Thank you very much.
Fantastic. Thank you, David. We're now looking to pass to, I think we should have Andrew Weller. There, oh, perfect. I can see you, Andrew. Andrew Weller leads business development for Glaciem Cooling, an award-winning Australian company enabling commercial and industrial users to decarbonise their heat and cooling energy needs. I'd like to introduce you to Andrew and Glaciem as one of our core industry Race for 2030 partners and also a leader of a fast track project under Race for Business. Welcome, Andrew.
Thanks, Danny. That's great. We're also members of A2EP, so both of the conveners of this conference, and it's great to be talking to you today from Ghana land in Adelaide. We do three things. We do CO2 heat pumps, we do thermal energy storage, and we do smart software that enables you to understand your demand, understand where you're getting power from, and to be able to manage the energy flows. Energy flows around electrical energy, but energy flows around thermal energy as well. When should you charge and discharge the various devices and storage that you have available? And what should you do with the power that you're generating? Where can you make money from it by putting it in the grid? And where can you buy energy from at the lowest price and use it at the right time to leverage those opportunities? Next slide, please. So we work in a number of key areas. So we work in cold storage, which is about refrigeration and keeping things cool. And we bring some patented technology that we've engaged with in years past with the University of South Australia that enables us to get the most efficiency out of CO2 systems that are providing refrigeration for that sector. We work in food processing where you've got heating and space heating and cooling demands, as well as refrigeration and blast chilling. And we work in straight out and out refrigeration settings as well. So cold storage, cool rooms, refrigerators, and HVAC, so space heating and cooling for buildings. We do that in greenfields and retrofit in settings, so old buildings and new ones. And it's about being able to maximise your use of renewables and drive towards zero carbon and decarbonisation. Next slide, please. So what is thermal energy storage about? Most people probably don't know the concept. It's about a thermal battery. So next, could we start that video, please? Yeah, thanks. So in the past, we would use energy from somewhere in the grid, and we would use that to, you know, perhaps it might be gas or it might be electricity. We would use that to create heat and power. But now what our smart software does is enable you to choose the best place you take your energy from, and to use that electrical energy to create thermal energy. So that's a refrigeration system, for instance, that can store a lot of energy in a small space using a phase change material. And then that can be used at a different time, perhaps, for process cooling, commercial HVAC, and for other cooling and refrigeration demands you might have. So typically that approach has been done using refrigerants like glycol and chilled water. And our fast track project with Race for 2030 enables us to do that with the natural refrigerant CO2 to improve the overall performance. And you can see what that does in the right-hand side there. It enables you to match your energy use, the timing of your energy use, with when the duck curve, when the solar energy is available, for instance, or other renewables are available from the grid. Next. We go to the next slide, please. So what exactly does this look like? Well, we're going to give you a time-lapse video of the build of a thermal energy storage tank. You can see it's a large stainless steel tank. It's got quite a bit of structure because it weighs 43 tons, and it enables us to store safely, a large amount of phase change material. Having created the structure that it goes in, there's a manifold that is, you can see on the floor there, that's going in to the roof of the thermal energy storage system, and 14 kilometres for each of these tanks, 14 kilometres of HDPE piping, which enables us to distribute the refrigerant throughout the phase change material to enable us to store rapidly and discharge rapidly large amounts of thermal energy. Finally, we put a skin, a insulative skin on it, and the plumbing that enables it to be connected to the industrial or commercial applications that you might have. Next slide, please. So we've applied this technology in quite a number of areas. So first of all, we've done it in a dairy and at an apple orchard or an apple storage and processing facility. Both of these have one characteristic, and that is that there's a mismatch between the time when they need heat and the time when they need cooling. And the thermal energy storage system allows them to create free cooling when they're doing the heating in the hot water that's required for a dairy to wash down the dairy and sanitize equipment. In the case of the apple orchard, they use hot water for the apples cleaning and waxing, and then to store the cold for use to offset the cooling demand at other times. So both of these sites, it avoids the need for a gas boiler and enables them to maximize the use of renewables. Next slide, please. We've also got a large installation at a winery, which is integrated with their existing ammonia refrigeration plant. And at Reef HQ in Townsville, the headquarters of the Great Barrier Reef Marine Park Authority and the largest captive coral reef, or the largest coral reef in captivity, as well as the building HVAC management for an office building or commercial building. All of that is provided using the Glaciem technologies and the thermal storage. So this enables them to do load shifting to match their demand with the availability of renewables and avoid spilled behind the meter generation. And both of them, again, can avoid using a gas boiler. Next slide.
Thank you very much, Andrew. That's a fantastic summary. I know that there is lots more to see there, but hopefully we'll be able to hear a bit more from you as we go into our question and answer session. And just to remind those here, we do have a 15-minute block to ask further questions and spark some discussion amongst the panelists. So if you'd like to pop a question in the chat, that would be very welcome. So from here, I'd like to introduce Steve Hoy. Steve Hoy is CEO of Audacious Australia, which aims to disrupt the power industry through the development of innovative energy traceability, trading and settlement solutions. He is a global industry executive and a recognised subject matter expert in smart grid and DER management systems. So thank you so much, Steve, for joining us. Over to you.
Yeah, thanks, Danny, and welcome to everybody. I'm speaking to you from the traditional lands of the Guringai people. And yeah, looking forward to introducing everybody to the idea of 24/7 traceability. Yeah, we've built a product at Untitled called Power Tracer, and it is, we believe, the world's first grid scale trading and traceability solution. And the reason we built it is to give everybody on the planet access to renewable power. And our view on that is that that essentially, we can put renewables on our roofs, and maybe 30% of Australia has already done that, and we could get to 40-50%, but that still leaves the majority who can't. And so what we're actually aiming to do here is provide direct access to wholesale renewables, wind farms, solar farms, and prove that that is the case. So that's what PowerTrace is all about. Next slide, please. So to talk to the corporate case, and largely what we're discussing in this forum, yeah, we have a number of corporate clients and plenty we're talking to who's clearly have strong strategic goals to reduce their scope 2 and emissions, and also their scope 3 emissions, and we're seeing some alignment of those things in the ability to do things like, from the scope 3 emissions perspective, support staff working from home, and also provide renewable energy solutions outside your own consumption, that is to your ecosystem, your supply chain, or even your customers. And all of that, in our view, is great. It's going to, what we're looking to is to increase the uptake of renewable power, and it helps us get to net zero under current processes. But there's a stronger and higher goal that we want to achieve. I might go to the next slide, please. And that is this notion of 24/7 traceability. So we've been on this for a little while, but our case was greatly advanced late last year by Google Corporation, in fact, Alphabet Corporation and the Google product. And Google have been provider of data center services to the world for quite some time. One of the biggest users of electricity in the USA, and in fact on the planet, I expect. And they had made a commitment 5+ years ago to be 100% renewable in their power purchasing. They achieved that through a series of PPA type contracts around the world, including the purchase of renewable energy certificates of various types in the various jurisdictions. And that was fine, but their own engineers kind of took them to the point, if you like, they called them on this and said, well, that's fine, except the fact is that when we buy energy from a wind farm to power our data center here in, say, Iowa, which is the example on the slide there, then in fact, something like 60% of that energy is provided by the wind farm at the time that we're using it. And the rest, we in fact are buying from fossil fuel sources. And what we've done with our money is buy renewable energy certificates from this wind farm and from others to offset our consumption for the rest of the time. Google decided to set the bar higher and said, we're not going to just offset our renewable energy, our non-renewable purchases, we're going to eliminate them. And so the idea of 100% renewable, 100% of the time, or flipped on its head, true zero carbon as opposed to net zero, so because you're not netting off by use of offsets, was promoted by Google. They set by 2030 they're going to achieve that goal. In the tech sector, there was a major pile-on over the next 6 months. So this was announced about October last year, and over the following 6 months, we saw Microsoft say, hey, we're doing the same thing, we'll set the same goal. IBM announced that they're going to achieve the same 100% renewable target without the use of offsets. Salesforce, Hewlett-Packard, IBM, Adobe, IKEA. And then in April, the US government made it part of their infrastructure plan that by 2035, all US government buildings would have achieve this same goal, renewably powered without the use necessarily of offsets. Which is 24/7 renewable power. So our view is that that's raising the bar, that that the leaders in sustainability have gone from net zero to true zero as their objective. But not everybody's Microsoft or Google. And so from my company's perspective, we're providing solutions to allow anybody to do that same measurement And we'll do it by providing the technology through retailers, who indeed are the only people you can buy electricity from if you're below the wholesale level. To that end, also, there's an organization called Energy Tag, which has emerged in Europe in the last year as well, who are aiming to facilitate this same idea of time matching your consumption against the actual production of renewable energy. And they plan to do it with the design of a new REC, a new renewable certificate, that you can only surrender if you can prove you used energy in the same hour as it was produced. And of course, without double counting. So that is that's the kind of context of what we're working on, and we think an important theme for people to get their heads around in the development of sustainability goals. Next slide, please. So how might then organisations seek to get to 100% renewable on that basis? Well, we see it really on two sides. There's this slide talks to the supply side. So you may have a solar farm PPA today that provides your energy, but if you layer on a wind farm contract, then you can probably go from 30–40% renewable to 70% actual matched or better. And of course, we can add in additional resources to fill in the gaps, be that hydro, geothermal, batteries, or indeed thermal storage through our friends at Glaciem. So whatever it is, this is the path to 100% renewable energy on the supply side. On the demand side, and again alluded to through thermal storage and battery operators, you can move your demand to match when the renewables are available. And what our view is that to avoid the kind of double counting, we need to actually account for who's bought those renewables. If you've bought them, if you have a commercial contract, then that's what we would apply Power Tracer to do the matching. And so what we would then be aiming to do is have our corporate customers trace their energy supply back to source, and we'll report to them exactly how much of their energy is coming from what sources at what time of day. And they'll be able to shift their demand to take advantage of the availability of the resources that they have actually contracted to buy from. So that is, and this is indeed what Google are doing. So for instance, in Google's case, they're doing things like shifting actual computing load from the east coast of the US to the west coast to follow the sun. They're doing things like pre-cooling their buildings when the wind's blowing. And we believe that that kind of opportunity will emerge for all consumers. Next slide, please. So just quickly, what is Power Tracer and what does it do? For generally, this question is always going to come up if I don't answer it here and now. Power Tracer takes smart metering data. So the certified information that is used for to settle the trades and purchases of electricity in the markets, and it's time stamped. We take it from both the consumption side and production side. We integrate our product with retailers primarily to identify at what who's contracted to buy what. We then match according to those contracts, and that may include things like dispatch order, who's got the first use of the energy, who has second, etc. And we apply our algorithms to determine the actual match of production to consumption. And Power Tracer also puts a price on that energy, and we report that back to the retailer who's provided us the data and the contract information, so that they can settle the retail products, or indeed CFDs or other more complex products that are linked to the actual match of energy. So to simplify that for you, imagine a two-part energy tariff. Here's the price when the sun's shining on the solar farm in Western New South Wales, and here's the price when it's not. So that's basically what Power Tracer is. And I might just skip a couple of slides if that's okay. Next one, and the next, and the next. Just to might stop here for a second. Here's a quick example of what Power Tracer can do. So this is the data for the head offices of Canva in Surrey Hills in Sydney, and what they're doing here is tracing their their energy to a pair of solar farms, in fact, where they have a PPA contract in place with the Park Solar Farm and the Griffith Solar Farm, contracts that are provided to them through Simply Energy. So the data is provided to us by Simply and Neoen, the owners of the solar farm, and we are looking here at the 24-hour load profile of a particular day for Canva, and the user has hovered over the Park Solar Farm, and it's showing them exactly how much of their energy came from that particular renewable resource. If they were to hover over the next one, it would show them how much was matched to Griffith, and the next one would show them how much was not matched to either of those. We call it the residual. And this, of course, can now be used to inform Canva of the actual renewable match and on their path to true zero. So I might finish up there and go to the next.
Thank you very much, Steve. And I think before I hand over to our last presenter, I just also note, in case you're hoping to get a sneak peek, Andrew and Steve, there are questions in the chat for you there, which we'll start answering soon. But before then, I'd like to introduce our final presenter today, who is Dr. Dorota Blegal, who is previously a researcher and now works with Race for 2030 industry partners, building capacity within their organisations to accelerate the uptake of innovation within the energy transition and decarbonisation as well. So welcome, Dorota. We look forward to hearing from you.
Thank you, Dani, and thank you and warm welcome one more time to everyone joining our conference today. The pathway to decarbonizing Australian business has a really clear goal, but it does require strong commitment and obviously innovation to get us there. So the role of technology in this transition and the fabulous products and services presented by the previous speakers, this is extremely important, and this is really why Race supports the industry in looking beyond their business as usual, and really through that enables the impact-focused R&D. But this is definitely not everything what we do here. At Race, we recognize the importance of looking at the energy transition in a very holistic way and seeing Australia as one big ecosystem where every person, business, and organization plays an important role, and everyone is racing together to the net zero. So today I would like to bring your attention to the role of capacity building, which is very often overlooked in this transition, while in the same time being crucial in decarbonizing your business and your organization. It really is the internal capacity of your team that allows you to absorb the Race-developed innovation and translate it into an action plan. So with all the beautifully designed net zero strategies for your business or organization, it is really the time now to ask yourself a question: do I have people within the structures of my organization that are actually able to implement this strategy? And if the answer to this one is no, it is time to start to build the capacity. So for the last few months, I performed extensive research into this space, talking to the largest emitters in Australia. And I attempted to identify the skills of the future workforce needed internally to bring the Australian businesses to the net zero. And really this research gave an input to one of the fantastic projects that Race is launching in the near future, which I'm presenting to you today. In this project, Race will support its partners who are significant emitters in facilitating a new job position within their structures, the carbon manager. So who is this magic person? The carbon manager is definitely an innovator and a change maker, but it is really a person who is hired for the sole purpose of reducing the greenhouse gas emissions of an organization and really bringing it to the net zero, to carbon neutrality. A carbon manager is a person who really deeply understands the operation of your business and identifies the opportunities for improvement. And I think what's the most important is the fact that carbon manager must be empowered to implement the proposed changes. But the role of carbon managers, they go beyond just emission reporting and commercially available solutions. Carbon managers facilitate the innovation in the space. They help to absorb emerging technologies and bring all stakeholders with them on this journey. So to give you a little bit more details, over 1 year of the pilot project, RAISE will provide financial incentives to 5 of its partners to hire a carbon manager. But we will also support the partners in identifying the skills that are missing and are really needed to decarbonize the organization. So really tailoring the profile of the carbon manager to fit the particular needs. We will also provide ongoing mentoring and upskill opportunities for the carbon managers to enable smooth and very effective delivery of the decarbonization initiatives. And I think this is a really fantastic opportunity for the current and future RAISE partners who are ready to onboard the innovator. Results of this pilot project in terms of achieved and projected emissions and energy usage reduction will be shared with the broader public. And this is how we really want to validate this initial hypothesis on the need and effectiveness of the carbon manager in Australian workforce. And I guess polish up a little bit the standard job description of a person. During this project, we also want to test different change management techniques used by the carbon managers to maximize the impact and identify the most effective ones, given the particular type and, of the organization and obviously an industry sector. But assuming project success, in the future, we are looking to partners with state and local governments to enable rollout of such program on much bigger scale. And this is because we at RAISE see carbon managers as a really integral part of the future Australian workforce ecosystem. But there are also other really exciting topics yet to be explored in that space. As an example, perhaps there will be a need for development of training and certification programs for carbon managers, or setting up an association, so building the support and knowledge exchange platform for future carbon managers. I would also like to mention, use this opportunity to mention that, in fact, we actually already started the trial run for this project through our collaboration with the Department of Planning, Industry and Environment of the New South Wales Government, who is our partner. And in this project, we deployed one of the carbon managers to work with the largest emitters operating in New South Wales in the state. And I really hope I'll be able to share a little bit more juicy updates on that in the near future. But in the interest of time, that would be the end of my presentation. What is a short snapshot of what I think is a really exciting and great opportunity to explore. And it is definitely not the only way how RAISE is planning to help you to build the capacity of the Australian industry. So we are waiting for your ideas, and I'm very much looking forward to the next part of this conference, that is the discussion in the breakout rooms, to hear your thoughts and see how can we support you in your transition to the net zero. Thank you, Dani.
Thank you, Dorada. That's fantastic. We actually do already have a question in the chat for you too, which I will ask second. So to give you a heads up there too. I was wondering if maybe we could then go into gallery mode now, and I'd like to invite Chris Langley to ask his question I think it's to Andrew. And we'll kick off our panel discussion. And also I should mention, sorry, I just saw a question directly to me. This recording will be made available following today's session to everyone as well. So Chris, if you are there, if you could come off mute.
Sorry, there we go. Thanks, Dani. Just realised I had a hardware switch on my mute as well as a software one, just to be doubly sure. Yeah, so thanks, Andrew. I know we've already chatted directly, but we just wanted to make sure everyone else had the opportunity to hear the question and the answer. What I was asking was a lot of the challenge we're finding with thermal storage is obviously with food and beverage players, particularly a lot of their legacy equipment, which has an enormous replacement cost to the extent where it's not even a consideration. They run on existing either direct expansion ammonia or lesser to that extent these days, but more often glycol. And so we're basically finding a gap in the thermal storage market, obviously in that sub-zero area, and being able to integrate it without necessarily replacing that legacy glycol secondary loop.
Thanks for your question, Chris, and perhaps just for everybody else's benefit, essentially what this looks like is that there's a refrigeration plant, and in Australia it's very common that is ammonia. Ammonia is quite a toxic and difficult refrigerant to manage, and these sort of applications often have very large storages of ammonia. So of itself, that's an interesting challenge, and Glaciem has solutions in that space for CO2 as a refrigerant. But what we do in thermal energy storage isn't so directly reliant on that. If you want to use our CO2 systems for refrigeration, that's fine. But if you're also going to use our thermal storage, you may do that with your existing refrigeration systems. And so in large part, just exactly what Chris is talking about is the sort of integration that we provide. Of course, if you're going to have a battery, you need to have spare capacity to charge it. And in the case of a thermal battery, you need spare capacity in your refrigeration plant. But if you have that, perhaps only at certain times of the day, we can leverage that spare capacity in your refrigeration plant, if it's ammonia, to charge our thermal energy storage solution. So that may be directly with ammonia, or it may be through glycol. Glycol is a frequently used secondary refrigerant that enables people to use temperatures below zero. If they're using chilled water, of course, it will all freeze in the pipes if it's less than zero. So glycol enables you to use much colder temperatures than that. And Glaciem can provide thermal energy storage that uses the appropriate phase change material for your application. So if it's a HVAC application, chilled water may be appropriate. If it's a industrial application at -6 or -20, then we have the solutions available in the phase change materials that enable it to change temperature, it to change phase, to change from a liquid to a solid, or a solid to a liquid, depending on whether you are charging or discharging. We have the right phase change materials to enable that to happen. And it doesn't impact your existing plant. So the equipment that you have on your plant floor that is using the ammonia or is using the glycol, it doesn't impact that directly. It just reduces the load on the refrigeration plant when you are discharging your thermal battery. So I hope that explains it, Chris. I think you had a follow-on question. I can't recall what it was now.
I think it was actually. I think it was.
Oh, you asked about dew point cooling.
Oh no, I think that was. I don't think that was myself. I think that was Chris Dunstan who asked that.
Oh, sorry, Chris.
Yeah, two Chris's.
Yeah.
That's always the case.
I'm probably monopolising things. I'll let Danny and Co decide who the next question should be.
Well, I was actually going to invite you, Andrew, to ask your question. I think that you posed to Dorota, if you would.
Oh yes, thanks very much. I do appreciate the opportunity. Good presentation, Dorota. So I was interested in what disciplines you think that carbon managers are going to come from, because there's people working in sustainability, but in my experience, they then have to defer to, for instance, mechanical services specialists who are familiar with what they're doing down at the sort of end where we operate, which is the thermal energy end, or perhaps it's electrical engineers working on electrical stuff and that sort of thing. So I just wondered what your experience has been and where you think those skills are coming from.
Thank you, Andrew. This is a really good question that we were trying to really answer during all of the research that I was doing before we started designing this program. And there is no one answer to this one. In fact, when I was talking to all of the heads of sustainability, energy procurement people, facility managers, they all actually come from totally different backgrounds, with the, I guess, majority of them having this engineering degree somewhere in the past. But in fact, I think what we are doing here is really an innovation. We are designing a completely new set of skills, and hopefully one day we would be actually seeing a degree that says carbon manager person, carbon manager engineer, or carbon manager specialist. And that is simply because there is no one person who is across all of the technologies that are needed right now for the business to really decarbonize. So you see the emergence of people, of teams that are working across the sustainability and energy. And I guess this is how we are trying to tackle this this problem right now. Hopefully in the future, Andrew, I'm looking forward to the new degree Carbon Manager.
Fantastic, great answer.
Fantastic.